So children, in this video we will talk about band theory. Band theory is a very important theory which explains about the conductivities of metals, semiconductors and insulators. So first we need to know what is band and how it is formed. We all know that in a crystal of metal there are many metallic atoms. So the atomic orbitals of all those metal atoms, they combine together to form molecular orbital, and when all the molecular orbitals are taken together, they are known as band. This set of molecular orbital is called band. Say for an example, if we have n lithium atoms and the valence shell of lithium atom is 2s1, which contain one electron. 2s is the valence orbital which contain one electron. So n lithium atom will have n 2s orbitals, and they will form n number of molecular orbitals like this. So in this diagram we can see that there are n number of lithium atoms, and these lithium atoms, they are combining. The orbitals of these lithium atoms are combining, and they are forming a partially filled band of 2s orbitals, 2s molecular orbitals. In fact, partially filled band of 2s molecular orbital. Why I am saying partially filled band? Because there are maximum 2s2 electrons occupied in any 2s orbital. 2 electrons can be occupied, but in case of lithium there is only 1 electron in 2s. So the band formed by the 2s molecular orbital will be half filled and half empty. This part is the filled part and this is the empty part. So this is the partially filled band of lithium atom. Similarly, we can see the band of beryllium atom, but in case of beryllium the situation is little bit different. The beryllium electronic configuration of beryllium is 1s2, 2s2 and 2p0. So valence shell here contain two orbitals, s and p. So when the band will formed, 2s orbital will be completely filled, but 2p orbital will be empty. So in case of beryllium the band is formed like this. This is the band of beryllium. This is the entire 2s and 2p orbital which are forming the band. These are the molecular orbitals and they are forming the band, and here it is an overlapping between 2s and 2p. So this kind of band is known as overlapping bands. Overlapping band because half part, the 2s part is filled while the 2p part is empty. This empty 2p part is known as conduction band, and this filled part here is known as valence band. In case of overlapping band, we always see the part which is empty, that is known as conduction band, and the part which is filled is known as filled bands. So in case of metals, what generally happens, the gap between valence band and conduction band is negligible because it is overlapping, so there is no gap you can see between valence band and conduction band. So when the electricity is passed, what happens, electron can easily move from valence band to conduction band. Electrons can jump from valence band to conduction band, and in this way the conductivity happens in the entire crystal. So this is the case of metals actually, where the gap between valence band and conduction band is negligible, or we can say zero. So electron can easily able to jump this gap, and from valence to conduction band they can flow very easily, hence they show conductivity. But in case of non-metals, in case of insulators and semiconductors, what happens? At first let us see about insulators. In case of insulators, the difference between this valence band and conduction band is very high. This energy is very high, and this large energy gap is known as forbidden zone. Like diamond is an insulator where the gap between valence band and conduction band is about 520 kilojoule per mole. So it is very difficult for any electron to cross this large energy gap and jump from valence band to conduction band. So insulators doesn't able to conduct electricity. In case of semiconductors, what happens? They are having this band gap, but this band gap is relatively small. This band gap is relatively small with respect to actually insulators. So if energy is given, like if the temperature is increased, the electron can able to pass from valence band to conduction band. So this is the way how semiconductors show conductivity. In case of metals, there is no gap because either it is partially filled or overlapping band, so there is no gap. In case of insulators, what happened, there is a large energy gap, while in case of semiconductors the band gap is small, so electron can able to cross this energy gap if they are given energy. We can see here the example of some peculiar metal, non-metals and metal insulators and semiconductors. So diamond is an insulator with band gap 520 kilojoule per mole. Silicon and germanium are semiconductors with band gap of about 111 and 63 kilojoule per mole respectively. Well, in case of tin, which is a very good conductor, we can see here that the band gap is only 0. So it is a very good conductor of electricity. This is the band theory through which we can able to explain the concept of conductivity in metals, insulators and semiconductors.